To really understand networking, we have to understand protocols. The core of networking is all about these protocols. So we're going to take a look at what they are, how they function, what they attempt to do. Not only that, but they interact with each other. These different protocols have to communicate or connect with each other. And that's where the OSI model comes into play. It lets us know how these different protocols interact with each other. So that's what this video is all about. Let's jump into protocols and the OSI model. Here's a map of a lot of the different protocols that we see out there. And this is downloadable online. So if you go and do a search for protocol map or network communication protocol map, you'll find a lot of examples of this. But essentially what this is showing you a map of a lot of the common protocols and how they interrelate with each other. So for example, I can scroll in on this section right here. This is HTTP and HTTPS. So these are the ones that are very common out there. If you're opening up a browser and you're connecting to a website, you're probably connecting with HTTP or HTTPS and then that's how that information is being delivered to it. So, and as we can see, there's quite a few more protocols here. So this map, we're not going to cover all the intricacies of what this map is telling us about. But really this module is designed to tell us how to even read this map. What is this map trying to tell us? Because at the top here, we see different protocol suites, and we'll talk about what protocol suites are. On the left here, we see the OSI model layers. And we're going to get into the OSI model layers and what those are. And then we see a lot of these different technologies, LAN technologies, we see WAN technologies, we see metropolitan area network technologies. So we see these different technologies out there and how they all interrelate. So once again, we're not going to cover all the details of this, but this module will start giving us insight on what this map actually is telling us. Now, if you are new to networking and you're learning this stuff for the first time, you may want to check out my networking basic video first. That will set you up for success in this video. This video can really be broken down into two parts. First of all, protocols, where we're going to study protocols and what they are, and then we'll get into the OSI model. Before I jump into the content, I do want to dedicate this video. I want to dedicate it to all my consistent commenters out there. I really appreciate all of your support. I don't think I would have made it this far without your words of encouragement. So thank you to all of those who consistently comment on my videos. So now let's kick things off with protocols and what these protocols look like. Protocols are a critical part of how networking actually happens. But what are protocols? Let's get into a discussion about what these protocols actually look like. Have you ever noticed that when you're talking to somebody really young, they'll just blurt out whatever they're thinking? And then as we get older, we start developing these ideas that we have to interact with other people in certain ways. There are certain unspoken protocols that we learn as we get older. And same thing with letters. When we're writing a letter, if we were writing a letter to a business, maybe it's for some sort of job that we want, it would be a very official. Try to turn that same format into a love letter, and it's probably not going to fly well, and vice versa. Take something that was written like a love letter and turn it into a business letter, and that probably won't fly well. So there are certain rules when we are writing stuff out or when we're communicating verbally, that certain rules that we follow. That's what a protocol is. When we're talking about networking protocols, we're talking about these rules that we follow. For instance, when we're talking about telegrams that are being sent back and forth between devices, how are we going to signal that other side saying, hey, we have a message to send you. Prepare yourself for this message. And then how are we going to convey with dots and dashes to the other side? Well, we're probably going to use something like Morse code. Well, Morse code needs to be defined what that is. And we need to be on the same page on both sides. We need to have that same understanding. There's a standard that's being set here. That's what a protocol is. Originally, protocol was used to describe how governments would talk and communicate with each other. However, we have adapted that now to exchange amongst computing devices. And so how do we transmit data between devices? The set of rules that govern that. There are a lot of different agencies out there that create protocols, these set of rules. In fact, you could create your own protocol. Probably wouldn't be an efficient use of your time because there's already great protocols that are out there. But you could create your own set of protocols. And actually, a lot of companies do. For instance, Cisco will create what's called proprietary protocols that you can only use those certain protocols if you're using their equipment. And there are some advantages to using those protocols that they create. Now, when we're communicating between devices, there are certain things that we're trying to accomplish. And so that's what a protocol does, is it sets up rules to accomplish some sort of task or solve some sort of problem that we're having. And so there's some common protocol functions that we're trying to overachieve some sort of common problem that we have. I'm going to use some Legos as an example of protocols and how they work. What we have right here is we have data. Let's say I have a computer that needs to make a request to a server. It needs to send data over. It needs to send ones and zeros to another server. It's going to request it from, let's say, a web server, and then some sort of information is going to be sent back. So how does that process happen? Well, it needs to be routed to that location in order for that request to be received by the server. So what we need to do is we need some sort of addressing with it. In this case right here, we need some sort of IP addressing, but we're just going to call it addressing for now. So I have this Lego block that represents an address, and it needs to be attached to the data so this request can go to that web server. Well, what this is right here is this has to be formed in such a way that it's very specific on what it looks like. Well, that's what protocols are. So this is representing a protocol. This is going to represent a protocol that is going to be addressing our data so it can be transferred to the proper location. So if I have a slide that represents this, this is what it looks like. I have some sort of data or payload here. And within that data or payload right there, I'm going to add information. Well, I'm just stacking it vertically since it's Legos, but I'm adding information for that delivery. Now, usually when I'm delivering data, I'm probably going to need some sort of addressing. In fact, I'm probably going to need multiple addresses with that. Not only that, but a good chance that I want some sort of confidentiality. The thing is that we probably need more than just one protocol to make this all work. So let's talk about these protocols and how they work together. Now, one thing to understand is that a protocol could do several different things for us. So maybe one protocol does error detection, flow control, and prioritization for us, while another does data sequencing and establishes end-to-end communication. And so maybe we want to use both of these protocols in order to help facilitate our needs and what we're trying to accomplish. I'm going to use these Legos as an example of how protocols work. So let's say here I have some data that needs to be delivered, and I need to deliver that data with confidentiality. And so this represents a protocol. This represents a protocol that will allow me to have some confidentiality of this data. So I'm going to attach this or utilize this protocol to deliver this data. Now this data will be delivered with some confidentiality. Perhaps I also want to make sure that it's accurate. So I need some sort of error detection that will accompany this. So I would choose a protocol that gives me error detection to allow that. Maybe it needs to be connection oriented. And of course, I probably want to do some addressing and make sure that it gets to the right location. So now I've created multiple protocols here. I've used multiple protocols in order to deliver my data. The thing is with these protocols is there's more protocols that are out there. I'm not just stuck with these protocols that I chose. In fact, what I could do is if I'm not happy with this level of confidentiality that this protocol gives me, I could choose a different protocol. Maybe it's one I've developed, or maybe it's one that's already developed. But I can choose a different protocol that will give me this level of security that I'm looking for this data. Now, there are a lot of different protocols that we can actually choose from. However, what I will say is that a few of these protocols have really bubbled up to the top as being the primary protocols that we use to establish certain aspects of here. And we'll definitely go over what those protocols are. And getting back to our network communication protocol map, these are all the different protocols that are out there. And we see that it's sorted by color because often these are the protocols that work well together. And in fact, most of this course, we're really going to be covering more this TCP/IP protocol stack right here. So we're going to be talking about stuff in this column right here mostly. This is where our things like our web traffic comes into play and things like Ethernet. And so these are the most common protocols that we work with in today's age. You know, our protocols try to solve some sort of problem or come up with some sort of solution. They're performing a function. Let's take a look at some of the common functions that our protocols help solve for. Now, there's lots of functions that protocols do, lots of things that they're trying to accomplish. And we're going to get more into that in future lessons. In fact, the ones that I'm going to list out here are just highlights of what these protocols do, and we'll actually get more in depth in future lessons. So I don't expect you to become an expert at all of these by the end of this lesson. Really, the goal is to create a firm foundation that we can build off of. So we're going to talk about what formatting and encapsulation looks like, and then I'm going to show it to you on Wireshark and see what it actually looks like. We'll also talk about addressing, and then we'll take a look in Wireshark where the addresses are at. And then we'll talk about segmentation and data sequencing and how we sequence these packets. And then I'm going to show you how that's done in Wireshark, where we see that in Wireshark. We're going to do that throughout this. We're going to establish end-to-end connectivity. We're going to talk about error detection and control. We'll talk about flow control. We'll get into prioritization. We'll also talk about delivery options and response timeout. One thing our protocols do is define some sort of formatting and encapsulation. That is, the data that we have need to arrive in certain formats for that whatever's receiving it to be able to understand it. Also, just to send that data, we need things like addressing. So we need to add information. We add information in the form of headers and trailers so that way it can be routed to its destination. I wanted to give you some perspective on what we're actually looking at when it comes to Wireshark. We're going to open up Wireshark and we're just going to capture some data with Wireshark so that way we can take a look at it and see what it actually looks like when we're talking about these different elements. Now, don't get confused with all of this. You know, this is just to give you some perspective on what we're talking about, but it's not my intention to get really deep into the weeds at this point in time. All right, so let's take a look at one of these packets and see what it looks like. I'm going to select this TLS version 1.2. I'm going to open up this last section right here, which is the data that's actually being transferred back and forth. In fact, we see encrypted application data. Here's this actual string, the encrypted string of the data that's being transported back and forth. So the first thing I want to talk about is the formatting. This is the data right here, and there's other information that's added to here. We've got says it's an application data 23, TLS version 1.2. or 0303, and the length is 38. So what Wireshark is presenting here is 23 is the actual data. 303 is the actual data. 38 is the actual data. This string right here is the actual data. Wireshark translates for us. So this 23 translates to application data. This 0303 translates to TLS version 1.2. And then 38 is just 38, and then this encrypted string is just the encrypted string. And then it knows that what it's going to receive first is whatever type of packet this is, and this is application data. So the content type is what it knows that it receives first. So it's labeling this as being the content type. It's labeling this as being the version. It's labeling this as being the length. It's labeling this as being encrypted application data. It's labeling that because it's already predefined format. So Wireshark knows that is the format. Now, if you want further proof over this, what we could do is we could go to View and say Bytes and expand this out so we can actually see the bytes. And what I want to show you, let's click 38 right here. So 38, it's showing you the actual bytes that were sent over. So all zeros, which is just 0. And then there's a 1 for the 32 right here. So that's 32 plus a 1 for the 4. So that's 36. And plus a 1 for the 2. So that's 38. So what we actually see is the binary form of what this data is telling us over here. We can do the same thing to here. This says 303. Well, this is 1 is the binary equivalent to 3, and so we see 3 3 right there. So everything is adding up so far. That is the formatting of this and the delivery from a format perspective. Now let's talk about encapsulation, because we've got the actual data that we sent right here, but it's being encapsulated by this TLS version 1.2. So this is additional information that's added to it so it knows how to read this data. We also see this transmission control protocol. That's an additional level of encapsulation that happens to this because it needs to be delivered. So we see information in there. There's an extra one. Here's internet protocol. So that's an additional encapsulation that happens to this packet so it can be delivered. Then we see Ethernet 2. That's an additional encapsulation that's added to it. And then the frame. So that's an additional. So in total, we have 1, 2, 3, 4, 5 different encapsulations essentially that happens to this to deliver this data right here. Many of our protocols add some sort of addressing. For instance, we need addressing to happen on a local level. So that's what one layer does. We also need to have addressing on a global scale. That's what another layer does. There's also the different ports so it can address which service it's attached to. So that's a level of addressing in itself. Okay, so what does addressing look like? Well, number one, we have the local addressing. So I can open up this Ethernet 2 and see that there's a source and destination MAC address. This is the MAC address right here. And this is what Wireshark is translating us and saying, well, this is a Dell on here and this is Microstar. So whoever registered these MAC addresses. So that is the local addressing there. I can also look at the internet protocol level right here and scroll down to see the IP addresses that's within here. So this packet, these are the two packets or two IP addresses, the source and the destination IP address. So we've got addressing there. And we also see the ports in here. So we got a source port and a destination port. So we have addressing on multiple levels with multiple protocols here. We also have that segmentation. That is, we need to break up big messages or big downloads into smaller messages so that way it can be better transported and received. Since we're breaking this down into smaller segments, we also need some sort of sequencing. That is, these packets could arrive in different orders. They could even take altogether different routes to get to the end destination. So because of that, this machine needs to know how to reassemble the data. So somehow we need to label this data so that way when it gets to the other side, this machine knows how to put it back together. Now, sequencing can happen on multiple levels, but for this particular one, the best example of this would be this sequence number right here. So this packet is 8,523. So this is the sequence number of this particular packet. Another thing some of these protocols do will establish or end a connection. And so before the data is sent between these two devices, maybe what needs to happen is a connection needs to be made first. This could even be a back and forth that happens to say, hello, I'm going to talk with you. And they say, okay, yes, let's talk. And so what will happen is there'll be some initial messages that are exchanged before the bulk of the data is exchanged. And then once the bulk of the data has finished exchanging, then some sort of end connection to disconnect these two devices. For establishing and ending connections, we can see this by packet by packet. There's multiple packets that get exchanged here. So in this example right here, what we're going to do is we're going to take a look at the communication between this device and some other device. And what we see here is that this first communication that happens is a sync, like, hey, let's talk. And then there's a sync acknowledgement that comes back, and then there's an acknowledgement. So this is a three-way handshake to set up the connection, and then we connect to the website. And then to terminate this connection at the end, there's this finish that happens at the end to break the connection back down. There's a couple things that can happen with our communication as well. Perhaps a packet gets lost along the way and never reaches its final destination. Or maybe a packet ends up getting there, but it's corrupted and the data is no longer good. So we need some sort of error detection, and we actually have multiple mechanisms that do error detection within our protocols. Now, error detection happens on multiple levels, and we see it at the Ethernet, we can see it at the IP level. So if I open up this right here, we see this header checksum right here. The header checksum is something that can identify if something's changed along the way. It's like a simple little thumbprint to make sure that nothing has changed. And so we've got that. There's also in this transmission control protocol, we have this acknowledgement number, which allows some error detection as well. And I'm not going to get into the details of how that works. It's a little more complicated, and so I'll have to create a whole video just for that. But that is how there's going to be error detection and multiple levels here. Another thing that we need to think about is some sort of flow control, some way to meter the connection or how much data is flowing back and forth. For instance, let's say this machine right here is sending a bunch of data to this machine right here. There could be a spot in the network that's getting congested and stacked up. Now sending more data along the line only compounds this issue and causes more of a problem. So there needs to be some mechanism in place that allows this device to throttle how much information is being sent, limiting how much information is being sent so that way we avoid any kind of congestion like this and making things worse. Here again, there's several mechanisms for flow control at these different levels here, but one thing that I will show you in the transmission control protocol, these acknowledgements that is sent back and forth and these acknowledgement numbers is something that can help with flow control. We also have something called window scaling. So this window size right here can help with flow control as well. So here again, I'm not going to get into the details of that. That's a little more complicated, but that's where we would find some of those elements within these different protocols. Another thing to consider is prioritization of the different information that's flowing across your network. For instance, if we have just regular data that's flowing back and forth, the time sensitivity is probably not as great. Like if you're visiting a website, we want that website to be responsive, but it's not as critical as if you're streaming audio or video, or even more importantly is if you have some sort of voice over IP system, some sort of phone system that's going across this connection here, you really don't want any delays with it because it could really lead to a very poor experience. So we need to prioritize those packets accordingly. Prioritization of packets can be a little more difficult. For instance, we might identify certain components, like for instance, maybe the protocol that's being used by the port numbers here, and maybe we prioritize based off of that. Although a lot of it is based off of like QoS settings, in which case we would do it like at the IP level and we'd have to implement some options to do that. There's actually, for like true prioritization, what we really have to do is take additional steps to set that up on our network, and then we incorporate it into our protocols here. We also need some sort of response timeout. There are times when things go down on the network, and so traffic is not going to ever get to the machine. And if it's waiting forever, that's going to be a problem. So there is some sort of timeout timer that starts, and when it counts down, perhaps it just gives up, or maybe it tries to do a retry and see if it can get that information again. So there's a response timeout that can happen. There are so many other options as well. So some of our protocols allow for additional options to be attached to these messages and sent across. And so that looks very different depending on which protocol you're working with, but there are different message options that can be added to this communication. These protocols have to work together to deliver data, but how do they plug in and work together? Well, the OSI model sheds some light on what that looks like. So let's jump into the OSI model. We're going to be covering what are protocol suites, we'll get into the OSI model, we'll talk about the OSI model layers, and we'll wrap things up taking a look at Wireshark and how the OSI model can be seen visually through Wireshark. You know, some of these protocols were designed by certain people or within certain companies or certain countries or certain time eras. And so they weren't really designed to interact with just any protocol, but specific protocols. And so we call that a protocol suite, a group of protocols that were designed to work well with each other, but not necessarily with other protocols. So let's get into what a protocol suite is and what it does. So here are some examples of those protocol suites. One example might be TCP/IP, where a lot of different companies and a lot of different organizations got together and created a standard that works well today and is one of the most prevalent out there. And then you've got companies that, when there wasn't as much of a standard, that would develop their own standards, like Apple. Apple developed their own standard for communicating across their networks. I'm going to use these Duplo Legos as an example of protocol suites. We have different protocols that were developed at different times in different countries by different people. And so largely these solve problems in a certain way, which might look very similar or different to another way somebody solved these problems. And so what we have is we have stacks of protocols that work well with each other, that don't necessarily work as well between each other. So a lot of times what we do is we use a whole protocol suite together. In fact, more often than not, that's the way it works out. So we're back on our network communication protocol map. And across the top here, we see our protocol suites here. So we've got TCP/IP, Unix, HP, Sun. We got Novell, Microsoft, SAM, IBM, ISO, Voice over IP, VPN/security, Apple. So these are the different protocol suites that we have. And then once again, it's color coded into these suites so that we can see how they interact with each other. We also have these little arrows. These little arrows tell us how these interact with other protocol suites. So for instance, we've got NetBIOS right here, and which interfaces with TCP. So the arrows kind of point from here, it points down to TCP, and over here we see that this one actually points up from TCP to NetBIOS. So that's the interconnection between these different protocol suites. The OSI model is a structure that helps us understand these different protocols and how they interact with each other. It helps us understand these protocol suites, and it helps us do things like standardize how these protocols interact with each other. So in this lesson, let's go over the OSI model and what it looks like. Protocols are like puzzle pieces, and they're really designed to interact with certain puzzle pieces. But the more other puzzle pieces they can interact with, the more interoperability we have, the more innovation we can have, the more that we can connect to different technologies. And so it really is to the advantage that we create some sort of standards that we can work off of. So that is one of the reasons why we created the OSI model. It actually does a few things for us, and so let's get into the OSI model and what it looks like. I'm going to use these Duplo Legos to help illustrate the OSI model and the advantages of the OSI model. So first of all, we have our data that needs to be delivered. So this one is representing the data to be delivered. Then we have our different protocol suites. So each one of these colors is a different protocol suite. And then we have our different functions our protocols are carrying out. And some of these are grouped up. For instance, let's say we have a protocol that does all three of these: segmentation, connection, and error detection. So what the OSI model does is allows us to group these into different layers, so that way we can better see what different layers do and the functionality of each of those layers. Now this has several advantages. One of the advantages of the OSI model is it allows us to teach what each layer does and what its purpose is. Another thing this does is it promotes interoperability. Now, each one of these protocol suites could be developed by a whole different set of people in a whole different country and have a very different way of interacting with each other. So it's not like Legos that are meant to click together. They have very different ways in which they match up and work together. But by laying this out in this type of structure, we can better create these linkages between these different layers. So now this protocol suite that does addressing really well can match up with this protocol suite that does segmentation, connection, and error detection really well, which can be measured up against confidentiality of this protocol suite. So now all of them can be created to interconnect together. And finally, what this OSI model does is it promotes the ability to do upgrades with this really well, because now there's a standard in how these two layers interconnect with each other. And so by establishing how that happens, now maybe we need to upgrade our segmentation, connection, and error detection to be the latest and greatest. So now we can take that out and implement it with the newest level of technology without disturbing the other layers. So now we can better develop our technology. This all happens because the OSI model helps define the different layers and the responsibilities of each of these layers. So back to our network communication protocol map, the one where we have our different protocol suites across the top here, and across the left here, we see the OSI model and the different layers. Layer 7, 6, 5, 4, 3, 2, and 1. Some of the common functions of each one of these layers and what job it's to perform, and how they're interconnected between these different protocol suites. And so this is a way that we can visualize the OSI model and the interconnection between these different protocol suites. Now, one thing to understand when it comes to these protocol suites is that as much as we'd like to think that it's as clean cut as this, it is just a model. That is, the model came out in 1984. A lot of these protocols were already well developed by 1984. And so even though that we've broken it down this way, things don't always fit great. Ethernet is a great example of that. Here we have our layer 3 across the top. Here's the network. And then layer 2 is this data link right here, and layer 1 is the physical. And as we can see, Ethernet doesn't really follow the same boundaries as the OSI model. So as the OSI model is a great model that we can work with, it's not perfect. The OSI model is really designed to work from the top layer and work down through the layers on one side, only to be unpacked on the other side. And what do I mean by that? Here we have a computer. And let's say on the computer, we have a browser open. We open up Chrome. And what that is, the application layer right there. Chrome is what does the presentation of the website to us. And we make some sort of request through the Chrome browser. The request that we make is going to be for some sort of maybe HTTPS service. It's going to be a web service. So over here on the server side, we have a web service that's running. So what needs to happen is this application, Chrome, needs to make the request. It goes to the presentation and session layer. At the transport layer, that request might be really large, and so we break it into smaller pieces. And so that's one of the jobs of the transport layer. It needs some addressing, so it adds some addressing in the network form. Then it also needs to communicate across the local network. So we add the data link and physical layer. So it builds up this frame that's going to be sent across the local network. It gets sent over, and many things can happen during this process of sending it over. But then essentially it gets unpacked. When this device gets it, it processes this data link and physical layer, make sure that it's destined for this machine right here. Once it does that, it no longer needs that and unpacks that, gets to the addressing and the network side of it and processes that. Once it is done with that, gets rid of it, takes the transport layer and processes that, and works its way back up to the application where it hands off to the web services, maybe in this case Apache, forms a response only to build a response to that request, build it back up to be sent back over where this machine then needs to unpack it on this side. This table illustrates the differences between each one of those layers. We have layers 7 through 1. And then there's the name of it. So it starts at the application layer and works its way to the physical layer. In this diagram right here, we have examples in which we'll go more and more in depth into each one of these different protocols and what the functions are. We also got the protocol data unit and what the protocol data unit is called, and visually what this looks like. So we just start out with data for the first few rounds of this. We add the TCP header to the data here, and then we have addressing that needs to be added from a global perspective, and then we have the local addressing that gets added. And so we add this up and then put the bits across the lines with the ones and zeros. Hey TechKnowStuds! In this lesson, we're going to get into the OSI model layers and start understanding what each layer is responsible for. We're going to start out at layer 7. And what I want to do is give an example of HTTP, one of the most common protocols that are out there. Or actually, HTTP is really being replaced by HTTPS. And HTTPS is the same thing, except for it's HTTP secure. It adds an element of security by using SSL/TLS to be able to secure or encrypt that data. So we've got this application layer, and we're going to actually treat layers 5 through 7 all at once here. We're gonna explain that all at once because HTTP really just has this one layer, this layer 7 or layer 5 through 7 or however you want to express that. It really doesn't do these separate connections. In fact, a lot of our common protocols nowadays are just these layers 5 through 7 is all just one layer here. So we've got HTTP traffic here. We call this data. At this point in time on these 3 layers, it's just data. If we were actually having these 3 layers separated out, there'd just be a manipulation of this data that would happen here. But we just call this data. So what does this look like? The application layer, layer 7 here, is an app on this side talking to an app on this side. It's just software. It's just a program that's running on either side here. On this side right here, since we're talking about HTTP, so we're doing all web traffic, we're going to open up a browser on this side. So the app that we're using would be Safari or Chrome or Firefox. Let's just use Chrome as an example right here. And it's connecting to some sort of software on this side. And so let's say Apache is running over on this side. So we've got our Chrome is going to be connecting to Apache. So Chrome needs to make a request to Apache. What it's going to use is this HTTP protocol. And so now we have a protocol that's associated that's going to make the request on this side to this Apache server, and then there's going to be a response that comes back. So that's the application layer. The application layer is just 2 applications talking to each other. Layer 4 is the transport layer. And we're going to use an example of TCP. TCP is a protocol, and it's one of the most common protocols that are out there for this layer 4 here. We call layer 4 the segment. And one reason is because we break this data down into smaller segments. So we've got data into a smaller segment here now, and we're adding some information here at the beginning. So we're adding a TCP header at the front of this. Here are some of the things that layer 4 is responsible for, especially TCP. So let's take a look at a few of these. First of all, we have segmentation. So in this case right now, we're requesting web services. And so let's say that message is really large and it needs to be broken down into smaller pieces. Now, in actuality, a request would just take a packet or 2. A simple request wouldn't be as 4 packets big. But let's say this is an awfully large request for some reason. And so now we need to break it down into these little segments. So we've got our segments here. And of course, since we have segments, we need to put it in a sequence. So we're going to add sequence numbers to it. Now TCP uses sequence numbers that look quite a bit different than this, but this will get us to the point of what it's trying to do. So it adds sequence numbers so that way this server knows what order those segments go in. And then another thing that this layer is responsible for is connections. So instead of just flat out making the request and saying, hey, give me this web page, what will happen is like a little introductory that will happen first. So there'll be a packet that's sent over that says, hey, I'd like to talk with you. And then there's a packet that's sent back and says, okay, let's talk. And then then there's one more exchange and says, great, we're talking now. So there's this 3-way handshake that happens. So it just establishes a connection. It also terminates a connection. So that's all part of layer 4 that's responsible for that. Another thing is that this server could have DNS running on it. It could have DHCP running on it. It could have our web server, so maybe it's got Apache running on it. It actually could have a lot of different services on it. So how do we address a specific server or service? That's where the ports come into play. So it's port 80 if it's HTTP, and it's port 443 if it's HTTPS. So those are the different ports that are running on this for Apache, so Apache can deliver this website. So what will happen is layer 4 will have that port that it's trying to address, the destination port. And if the destination port is port 80, then it's probably HTTP traffic, and it's 443, then it's probably HTTPS. Another thing that will happen is we got to count on some of these packets maybe not making it to its final destination. So what happens is that there's the sequence numbers that get sent over, 1, 2, and 4 get over here, and there's an acknowledgement that happens. And I'm not going to get in depth into what the acknowledgement looks like, but essentially the acknowledgement will flag that it didn't receive packet 3, and then this machine then will retransmit packet 3. So layer 4 is responsible for retransmission. And then we also have flow control. So the flow control here is there's an acknowledgement that happens every once in a while. And if this machine doesn't receive, or it has, it'll wait to receive an acknowledgement now and then. And so therefore, it will send a group of packets over and then wait for an acknowledgement. Send another group of packets over and then wait for acknowledgement. So it will wait for those acknowledgements, and if it doesn't receive an acknowledgement, then it will wait a little bit longer. So therefore, you don't get all this buildup, all this congestion. It just doesn't keep sending things over. So it's responsible for flow control. So that's layer 4. Now, one thing to note about this is most of this is really specifically talking about TCP, which is one of the most common protocols at layer 4. But if you're looking at UDP, which is another common protocol at this layer, it looks quite a bit different. So just because TCP has all of this, and we're going to talk about layer 4 having all of this, doesn't mean that every protocol has all of this. Next up, we have the layer 3, the network layer. The network layer, some examples of that is IP version 4, IP version 6, and ICMP, all common protocols. IP version 4 being our most common right now, but we're trying to transition that to IP version 6. This is called the packet. And so a lot of times you'll hear me refer to the packet because the packet remains the same going from location A to location Z. All the way along the way, it remains relatively the same. And so a lot of times we just refer to everything that we're sending over as being a packet. In fact, when I was talking about the segment one time, I called it a packet as well because the segment goes into the packet. We're just adding a header, this IP header, to the front of the segment. So we've got our segment, and now we've got a packet. The packet is the whole thing. And the biggest thing that layer 3 is responsible for is getting it to its destination. So addressing. We've got addressing and routing. So we have a machine right here trying to talk to another machine over here, and we add the destination IP address. We also add the source IP address, but the key to this is the destination IP address. It gets sent over and routed to this other location. Now the cloud, we just put it in there because it represents a lot of different routers. It'll go through a lot of different routers to get to its final destination and get routed to there. And we use the cloud because it's not all mapped out, and so it's just representative of all these networks that are in between these two locations. A lot of times when I talk about routing, I'll use this as an example instead. So if this machine is talking to this machine, we send over this packet and it gets to this router right here. And the router then chooses, okay, I need to get to this network right here to get to this location. So how do I do that? Well, I'm going to send it either this way, looks like I can get it there from there, or this way, I can get from there as well. So I'll choose one of these, I'll send it to the next hop, which then will send it to the next hop to be delivered. And it all does that based off of that layer 3 header, which has the IP address. And then for that local delivery, we have this layer 1 and 2. With layer 1 and 2, we're going to be talking about Ethernet. And Ethernet really straddles both layers 1 and 2. So we can associate this 100 base T and Ethernet. This is all kind of Ethernet technology arena right here. So we just call it Ethernet here. The protocol data unit, we call this a frame. And the physical layer, we just call bits. It's a stream of bits here. And so we add a frame, we had a header frame on here, or we could also add maybe a trailer at the end. And what this does is this just allows it to communicate on that local network. And the bits, there is a little bit that gets added with the bits. For the most part, it's just this little starter. We call it the preamble, something that just kind of wakes up the equipment on the other side. So maybe it sends a series of like 10, 10, 10, 10 to say, hey, I'm starting to this transmission. So you better wake up because here it comes. And the key to this is that this layer 2 is for that local delivery here. So it's just so it can send it on its local network to its destination, and then those will be dropped off only to be recreated on the next segment. Here's one final glance at all of those different layers there, and so they all work together to deliver data from one location to another. I do want to mention that a lot of the content here is taken from my Foundations of Networking course. This really is just a brief look into what the Foundations of Networking course really has to offer. Really, when it comes to these protocols and the OSI model, we're just scratching the surface. I've cut out a lot of content to make this more condensed and appropriate for YouTube. Really, this is just a few videos that I have in this module, Protocols and Standards. But I have a lot more content that goes a lot more in depth and explains this in many different ways. With the TechKnowSurge membership, you can gain access to all the lessons of this course. Not only that, but the activities and labs and things that I just can't offer through the YouTube platform. Not only that, but it'll track your progress as you go through these lessons. So it's a great resource. You'll also be able to enroll in a lot of my other core courses. It gives you a really broad perspective around the IT career and how to be successful in it. Not only that, but as I create new courses and bundles, you'll get first access to it. In fact, right now, I have a limited time offer for members who sign up. They can enroll in the Cisco CCNA certification bundle or the CompTIA Security Plus certification bundle. So whether you're going after your certification, trying to go after that next job, or level up your career, this is going to be a great package to get you to where you want to go. So don't wait, sign up for that TechKnowSurge membership. I got a link down below in the description. I'll also put a discount code down there. I created a little network in Legos to help illustrate the point of the OSI model and how it's used. So let's jump into it. So here's our network all laid out. On one side here, we have a local area network. So the local area network is all of these laptops that are communicating on this local area network, as well as this router is on the edge of this local area network. So this is one local area network over here. Over on the other side, we have another local area network. Both these local area networks speak Ethernet, by the way. This one right here is a laptop, and I'm going to host a website off of this laptop. So I install Apache on it, and Apache is going to be what I use to host this website. Now we have a machine that actually wants to access this website over here. So what needs to happen is that this machine needs to communicate across these routers. We've got router 1, router 2, and router 3 to this local area network on this side. So what it's going to do is it's going to go through the process of resolving and figuring out what the IP address of this machine is. And the IP address is 192.168.5.7. So we have that IP address over here, and we need to now route information from this machine, which is requesting those web resources, from this machine, which is hosting those web resources. So what we have here is we have data that needs to be requested. The data is going to be sent from this laptop over here across the routers to this laptop. And then there's going to be a response, and so a different set of data is then going to be sent back. So of course we have to make a connection here, and when this data gets over to this server over here, it's going to need to be routed to the proper program, which is Apache. The program over here, Apache, is tied to port 80. So there's some information that we need to get over here, and we need to address that specific service right there. So what we need to do is we need to put a TCP header on this. So this TCP header is going to be additional information that's going to be carried over here, so that way it can get to this the service, the proper service, which is port 80. So we've got that information in here that it needs to hit port 80, as well as quite a bit of other information as well in this TCP. So we're going to attach this or encapsulate the data with this TCP header, that additional information. Now, the other thing that needs to happen is this needs to be routed from router to router, because there could be many networks in between. So it needs to be able to route to this IP address. So what we need to do is we also need to attach the IP address to this. So this is the IP header, and there is additional information in this header, but for now we're just mainly concerned with this IP address. So we're going to encapsulate the data and the TCP with this IP header here. And that's going to be the information that's needed to route to this final destination. But the first step is that this laptop needs to send the information to this router. So that's the first thing that needs to happen. And it needs to have some local addressing here to be able to get it to the router. The local addressing is the MAC address. So the MAC address of this router is AB2C1244F112. All right, so we've got that information that needs to be sent there. And so what we do is we have the Ethernet frame right here that needs to be added to it, the Ethernet header that needs to be added to this. We need to encapsulate it with the Ethernet information. So the Ethernet information actually spans multiple layers. So we've got layer 1 and 2 all wrapped up into this. By the way, this is layer 3 and layer 4. This layer 3 is the IP and layer 4 is the TCP. So we've got this additional information, and the information is the MAC address, so it can be delivered locally to this router, as well as the layer 1. Layer 1 has some signaling to get the communication started. And it starts out with a bunch of ones and zeros. So I represented this by some ones and zeros here. This is kind of like a wake-up signal to get devices on this network listening. So I've got this layer 2 and layer 1, and I'm going to attach this to my data as well, so it can be sent over. Now what can happen is that this laptop can send this information over on the local area network to this router. So now this router receives this information, and it can take a look and see, oh, is this is once again the preamble here is like the little wake up signal, but it says, is this my MAC address? And it says, well, yep, that matches up. That's my MAC address. So now this layer 1 and 2 has done its job. It's no longer needed. So it takes this information and gets rid of it. So next what it needs to do is take this IP address and figure out what the next hop is. So it goes through the process of figuring out where it needs to route this traffic. And so what it does is it figures out it needs to go to router 2. So with router 2, what is the connection between these is a little different type of connection. We've set up between router 1 and router 2, not an Ethernet connection, but a point-to-point connection. We're using point-to-point protocol. So here's point-to-point protocol right here. This is a protocol that is many times used between routers like this. So this point-to-point protocol, and it just is a point-to-point. So there's just two devices on this network. So it just needs to send out, essentially it's a broadcast. It just needs to send out this broadcast to the other side so this other device receives it, which is all ones in the case of point-to-point protocol. So what we're going to do is we're going to attach this point-to-point protocol to this. So this is the layer 2 header, and that way when it gets over to this other destination, router 2, then it will be able to see where it's come from and be able to process that packet. But it's going across this link right here, which is physically set up as an ISDN line. And I don't want to get into the specifics of what an ISDN line is, but that's the layer 1 technology going between these two devices. And the layer 1, the ISDN starts out with a series of 1s, so I've got this represented here, and that's the preamble, the kind of the wake-up signal. So it attaches this now to this. So now we've got our new layer 2 and layer 1 here. And then it can be sent over to this router right here. That router is going to take a look at the layer 1 and say, is this for me? And once it, well, this is being sent over, woken up. And so yes, it gets this and it says, oh yeah, so I need to process this, takes away the layer 1. The layer 2 now right here, the point-to-point protocol says, is this for me? It says, yeah, this is for me. So now it no longer needs this. And now next it needs to take a look at the IP address and see where does it need to be routed next. And it determines it needs to be routed to router 3 here. So now the connection that we've set up between router 2 and router 3 is an HDLC connection. So now we've got this HDLC protocol that's set up between these two routers. So it's a much different protocol. And here's the address to it. We've got some sort of address marking on here. And so it needs to address this router 3 right here. And so we're going to take that HDLC, we're going to encapsulate our packet with it. But we also have that layer 1 connection across there, which is an RS-232. So we've got the RS-232 and what starts the RS-232 connection. So we're going to attach that here and we're going to send it across. So it's going to physically send that across now to router 3. Router 3 has this now, takes a look at the RS-232 and does whatever it needs to do with that and does away with that because it's no longer needed. It's got the HDLC, makes sure that it's addressed to router 3. Sure enough, it is. Sees the 192.168.5.7, realizes that that is a directly connected network and needs to send it to this device. This LAN over here is using Ethernet, so it needs to form a new Ethernet frame right here. So we've got the Ethernet information. This operates on both layer 1 and layer 2. So it needs to determine a MAC address. And so the MAC address of this laptop over here is 341F7A61BB4B. So there's the MAC address of this machine over here. So it needs to put that MAC address in this Ethernet frame. Of course, it's got the preamble as well to the little wake-up signal. It attaches this to this packet right here. And then it sends, in fact, I'm going to flip that around, and then it sends it into this network to be delivered. The switch then delivers it to that MAC address, so it gets here. This computer will take a look at this and say, okay, well, I need to process this. Says, oh yeah, this is destined for me. No longer needs that layer 2 information, takes a look at the IP, processes the IP, which does several different things, but the main one is, hey, is this my IP address? Sure enough, it is. Takes a look at the TCP right here. With the TCP, it looks at the port and says, oh, I know which port this is associated with. This is associated with Apache. So now what I'm going to do is I'm going to send my data to Apache so that Apache can process it. So the Apache program processes this data, realizes it's a request for some web services, and starts forming the reply back. And then the reply back then happens so that way the information can get back to this laptop. So that's how the different layers are. We've got the layers 5 through 7, the application layer. We've got the TCP, which is layer 4. We've got the IP, which is layer 3. And then we got the layer 1 and 2, which could be Ethernet, or it could be these other protocols that I showed here, HDLC with RS-232 or ISDN, and point-to-point protocol, or perhaps maybe we could have any one number of these different configurations, because once again, these layers can work together to provide all this communication back and forth. And we would choose which protocols we would use based off of what's available to us and what technologies and what we're trying to accomplish. Let's take another look at Wireshark again and see those different layers, the different OSI model layers within Wireshark. All right, I have Wireshark open and I already captured some data going between this demo laptop and my Pi. So I've got Apache running on the Pi and it's serving out websites. And so it made this request. Just notice here at the top, this is the handshake that happens that TCP makes before we make the request. And then we see this first HTTP traffic going across back and forth. It's a GET command, so it's asking for this website. So this is the one I'm going to use as the example. This is the packet, and down here below, these are the different layers. So let's first of all take a look at the hypertransfer protocol. So this is layer 7 on here, or layer 5 through 7. So I can open this up and take a look at some of the details of this. So it's going to ask for things like, this is the actual request it's asking for, is for 10.1.0.3. So there it is. So that's the layer 7 at work there. So then we go down to layer 4 that's added to there. And I said it adds a port to it. So we see the port number here. In fact, actually the destination port is the one we're looking at. So this is web traffic, so it's port 80. Also, I mentioned the sequence number, so we see the sequence number right here. I also mentioned that the sequence number can look a lot different. And we'll explain that in another lesson, but we're just taking a look at this sequence number, that's relative sequence number. This is, it's kind of interesting how it's displayed here, how Wireshark displays it. It's a cool feature of Wireshark. So then we also have an acknowledgement number that's happened, and I also mentioned that in one of my prior lessons. So there's some of the data that we find on the TCP, the layer 4. And as I mentioned before, I think the TCP layer is really cool. There's a lot of cool stuff that happens in it. The other layers are pretty cool too, but some of them are kind of boring. The TCP has a lot of cool stuff in it. So now we get to the Internet Protocol. So this is IP version 4. This is our layer 3. So we see that the big key here is just the source and destination address. No surprises there. So that's what we see there. So I'm going to close that. Then we've got our Ethernet. So I'm going to open up the Ethernet, and that's the MAC address. It's communicating Ethernet here. So we see the source and destination MAC addresses there. So that makes sense right there. And then I can close that out. Now, the one thing that we are missing here is that layer 1. The layer 1 for Ethernet is that preamble, the little ones and zeros that get sent over, so that way one NIC can wake up the other side and say, hey, I'm starting to talk, please listen to me. So that doesn't get captured in here, probably because the NICs just take that in, it wakes up and then it discards it right away and then starts processing the rest of the frame. So at the top here, it looks like it could be a layer 1, but technically this isn't really the layer 1. We could represent it as being the layer 1, but when we look through it, it's actually just some details, some summary information about this whole Ethernet frame. And just to prove the point here, I can click on the top here and it highlights all of the frame details. So it's just a highlight of all of the frame details. So you can ignore that for the most part right there. And we are more concerned with these other layers, layers 2, 3, 4, and 7, or 5 through 7. So I'm curious, what experience do you have with the OSI model, and which layer are you most familiar with? Put that down in the comments below. If you don't have any experience, put that down there too. I want to hear from you to hear what kind of experience everybody has. And when you're down there, don't forget to hit that like button. That really helps me out to get me recognized and able to do more of these type of videos. In my next video, I'm going to start jumping into basic networking equipment. So if you're interested in that video, click the link right here.